So now it's time to learn about the type of register in ARM version 8 architecture. If you refer to the ARM reference manual, you're going to see the type of the register in ARM version 8 architecture. The first type is general purpose register, and the second one is a special register, and third one is p-state. But p-state is not register, and it is not described as the register in the reference manual, but that it just acts like the CPSR register in ARM version 7 architecture. So this could be considered another type of register. And the last one is system register. So let's talk about the general purpose register in ARM version 8 architecture. Register X0 to X30, 630 is general purpose register. Every time you look into any assembly instruction, you're going to see the any of general purpose register. General purpose registers used as input to the register, and the general purpose register is used as the destination register. So what I mean is the result of assembly instruction can be stored in the general purpose register. So understanding how the general purpose register is organized is important. And as for X0 register, X0 register is used for the multiple purpose. It could be used as argument register, and when you return the value from the function, the return value will be stored onto X0 register. And X30 register is link register in ARM version 8 architecture. So we will deep dive into more about the general purpose register in the later lecture. And another type of register is special register. Special registers contain the information about control flow of the process. Example of special register is exception link register, SPSR-EL1 register. This register contains the information about exception, that is, when the exception is taken to exception level 1, the address at the moment of exception is stored onto this register, and the previous p-state is the backup is stored onto SPSR-EL1 register. So if you read the value of these two registers, you're going to see what happened at the moment of exception. So from debugging perspective, if you debug your own device driver, your own system, so checking the value of this register are extremely important. And as for SPEL1 register, this is the stack pointer register that point to the last executed the stack address for the process. So if you look into the stack memory dump, the first thing you have to do is to check the value of SPEL1 register. So understanding the special register is extremely important. Next one is p-state. Actually, ARM reference manual does not describe the p-state as register. But if you refer to the ARM version 7 reference manual, you're going to see the CPSR register. But interesting point is that bit assignment method for CPSR register is almost identical to p-state. The p-state that contain various bit field that include exception wrapper, exception bit mask, and conditional flag. Important thing is, in order to access the p-state, we need to check the value of the system register. Only through the system register, we can write the value to the p-state. For example, if we wanted to see the exception level from p-state, we need to read the value of current EL system register. And another important type of register is system register. The system configuration can be controlled using system register. For example, if you configure exception vector base address, we need to write the value onto and VBAR EL1 register, because VBAR EL1 register is to use to control the exception, the handling. And we have the various system register to configure So operation of the ARM version 8 architecture, and further the primary system register will be explained in the later lecture. In summary, ARM version 8 architecture specified 4 types of register. The first one is general purpose register, and second one is special register. Third one is p-state. The p-state is not register, but it is considered the important the register. And the last one is system register. Now, next lecture, we are going to look at the general purpose register in ARM version 8 architecture in more detail.